Each term consists of a coefficient followed by a variable raised to some sort of power. Y'all know what a power means? Exponent, right. Most of the polynomials we will deal with have integer coefficients, so their front number is a positive or a negative number. First word here that might be new, maybe it's not new. The degree of the polynomial is the highest power that appears on a variable in its terms. So basically the highest exponent that you see in the polynomial. So if we look at this one, I heard someone say it already, but what is the degree of this polynomial? 4, because that's its highest exponent. 4, because that's its highest exponent. Okay. How many terms does it have? How many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. Terms are separated by adding or subtracting. So we'll have 1, 2, 3, 4, 5 terms. Okay. The leading coefficient is just the front coefficient when it's in standard form. Standard form will always have the highest exponent first and kind of work its way down. So the leading coefficient on this one would be a 2, just its front coefficient. And then the y-intercept. Y-intercept is actually pretty easy to calculate when it's in standard form. If you plug in 0, what do you get as a result for the y? 54. Yeah, because this turns to 0, this turns to 0, this turns to 0, this turns to 0, and you just have a 54. Okay. It's very similar to working with a quadratic, just it has higher exponents. A polynomial can also be written in intercept form. We actually had intercept form when we were learning about quadratics. Intercept form is just basically the factored form. Each linear factor gives one of the zeros of a polynomial. So each of those factors gives you a 0. What are the synonyms we know for 0? Root. What else? What? X-intercept. Yeah. One more. What? Solution. Yeah, solution. Okay, so anytime we see zeros, we can think about it as a root, we can think about it as the x-intercept, we can think about it as the solution. They're all kind of synonyms of each other. So the zeros of this one, we'll take each of the linear factors and we'll solve them. So if I take x plus 3 and set it equal to 0, and solve it, what do I get for the 0? X equals -3. Good, there's the first one. What would the solution to the second one be, or the 0 to the second one? -1. Good. For the third one, x minus 2/5, set it equal to 0. What do we get for that 0? 2/5. And then the last one, x minus 7, set it equal to 0, and we get x equals 7. So the zeros are these 4 numbers here. -3, -1, 2/5, and 7. Bless you. Okay. So if those are the zeros, what are the x-intercepts? The same numbers. Yeah, it should be the same. The only thing I'd usually do different for x-intercepts is I'll write them as ordered pairs. So I'll have one at -3, 0, one at -1, 0, one at 2/5, 0, and the last one at 7, 0. But they're all the same numbers. How would we figure out the degree of this polynomial if it's in factored form? So remember, degree is the highest exponent. Do we have to multiply this out? Count how many x's there are. Good job, Val. That's what we want to do. How many x's are there? 4. So what's its degree? 4, right. 4, because there's 4 x's. So if you were to multiply it all out, you would eventually get an x to the 4th power somewhere. It would just take you forever. So we're going to avoid that. All right, some polynomial expressions can be factored using techniques we already know from the quadratics unit, including factoring by grouping. And I believe we even had this question or a similar question on our last review because it can be factored using a method we already know how to know. This one, I know it doesn't look like it, but we can actually use easy factoring on that. Is there a GCF we could take out first though? No big GCF. No big GCF. GCF, no. Okay. Second thing, I know it doesn't look like it, but you can factor it using easy factoring. That front number is a 1. And if you remember back to the review, okay, thinking about how we did this, okay, we're looking for two numbers that multiply to C, which is 16, but those same two numbers need to add to B, which is negative 17. What are those two numbers? Yeah, negative 16, negative 1. Double check, it does multiply right, it does add right. So the only thing we have to do different that makes it different than just plain old easy factoring and quadratic is the first two need to remultiply to x to the 4th power. So we can't just use x and x. What would we have to use instead? If you want to refoil it and get an x to the 4th? X squared, right. You need an x squared times x squared, and that's how you're going to get that x to the 4th. Okay, we found our two numbers. One's a negative 16, one's a negative 1. This is not the exact same problem from the review. This one's slightly different. Now, if you look at each of those, I can always tell something might factor more based on whether you still have a squared term left. And we do still have a squared term left. So we want to look at each of these and decide, does each one factor more or are they prime now? We can factor them more. What type of factoring are they? We had it in the last unit. Difference of squares. Yep. Each one is now a difference of squares. Difference of squares. And remember, a difference of squares actually factors into two factors. So this first one will create two factors. This second one will create two factors. How many factors is that total then? 4, right. Okay. For just the first one, remember how a difference of squares works. We'll start with, what's the square root of x squared? Square root of x squared. X and x. So each one gets an x. Okay. The second part is, what's the square root of 16? 4. And what do we do with our signs? 1 plus, 1 minus. Flip-flop. Yep. Okay, and same thing for the second one. The second one is also a difference of two squares. What's going to be the first term on each? X. Good. What's going to be the back term on each? 1. What do we do with our signs? Flip. 1 plus, 1 minus. Now the order you write these all in doesn't really matter. And I can tell this doesn't factor anymore because I don't have any more squared terms. So that's not possible. All the rest of these are just little linear prime factors. So I know it's not going to factor anymore. So this should be your final answer for this one. Okay, so that one we were kind of looking at easy factoring. Now looking at the next one, this one has 4 terms. Anytime there's 4 terms, you still want to check to see, is there a big GCF that you can take out? But you've got to be able to take it out of all 4 terms. Is there a number and or letter that could divide out of all 4 of those? Yes or no? No, there's not. Okay. So this one is actually, you know how when we're doing split the middle factoring and you take that middle term and you split it up and then you have 4 terms and you group the first 2 and group the last 2? This is basically what that is, picking up from we've split it up. Okay, so after that, what we're going to do is we're going to group the first 2 together. And we're going to group the last 2 together. So on this, what we're doing is factoring by grouping. Okay. And it works the same way we did split the middle factoring. We're going to look at that first group. What is the little baby GCF of this first group? 4x squared. Good. Okay. And then we're going to take each and we're going to divide it by 4x squared so that we can see what's left over. What would be 4x cubed divided by 4x squared? X. Good. And then 12x squared divided by 4x squared. Your x squareds will cancel and you just have 12 over 4, which is 3. Okay. For the back group, it says negative x minus 3. I know the GCF has to be negative something. What is the something, though? 1. Just a 1. So then I'm going to divide both by negative 1. Negative x divided by negative 1 is x. Good. What's negative 3 divided by negative 1? 3. Okay. At this point, we should have matching parentheses, do we? Yeah, that means we did it right. Okay, so one answer is going to be the x plus 3, the matching parenthesis. What's the other answer going to be? 4x squared minus 1. Okay. Now, one of these is a linear factor, so I know it cannot factor more, but this one still has a square in it, which means we still need to check if it could factor more. And the only possibilities for anytime there's two terms, it might not factor more. It might be a difference of squares, it might be a difference of cubes, or it might be a sum of cubes. Is it any of those? Again, our options were it might not factor anymore. It might be a difference of squares. It might be a sum of cubes or a difference of cubes, which is what we learned last time. It is a difference of squares. Both of these have square roots. That's how I can tell it's a difference of squares. So this one is going to factor more. Difference of squares. How many parentheses does a difference of squares create? 2. So this one is going to split into 2 parentheses. And then I'll just bring down my x plus 3. The first term on each, what's going to be the square root of 4x squared? 2x. So each one gets a 2x. Okay. And then the back term is going to be, what's the square root of 1? 1. And what do we do with our signs? Flip-flop them. 1 plus 1 minus. And double checking, I don't have any more squares, so that's how I can tell it's definitely not going to factor anymore. All of these are just little linear factors now. All right. Let's try. We've got a bunch of different factoring methods to try now. First thing I want to check for, is there a big GCF I can take out on this first one? Yes, there is. What is the big GCF? 2y cubed. Yeah. Now, just because we're taking it out, it is still one of our answers, so don't lose it. Okay, we're going to divide both by 2y cubed. 2y to the 5th minus 2y cubed. What does that become? Y squared. Minus 18y cubed divided by 2y cubed is 9. Okay. So the back parenthesis still has a square, so we still need to check, will this back parenthesis factor more? It is. What is it? Difference of squares. Difference of squares. Yep. So I'm going to carry over my GCF that I took out. I'm going to turn that y squared minus 9 into its difference of squares. What's going to be the first term on each? A y. And the second term on each? A 3. What do you do with those signs? Swap them. 1 plus 1 minus. Looking at it, neither of those parentheses are squared anymore, so I know these are not going to factor more. This one, I would just leave just like that is. Technically, if you want to, you could write y times y, but that seems silly. Like, just leave it as your y to the 3rd power. Questions on that one? All right, splitting it up for the next one. Okay, checking for a big GCF. Big GCF. Is there one that I can divide out all 4 terms? Nope. Okay. Straight from the front, what did we do when there were 4 terms? We grouped them. Yeah, group the first 2, group the back 2. Okay. Looking for the little baby GCF of this first group. What is it? X squared, right. And then we're going to divide both by x squared. X cubed divided by x squared becomes x. 7x squared divided by x squared becomes a 7. Okay. GCF of the back group has to be a negative something. Negative 9. Yeah, 9 goes into both of those. And then if we divide both by negative 9, the first one would be an x. What do you think negative 63 divided by negative 9 is? 7, right. We've got that matching parenthesis now. So one answer is going to be the matching parenthesis. The other answer is going to be what? The x squared minus 9. Now remember, anytime you still have a squared term, you still got to look at that and say, does this factor more? Yes, it's a difference of squares. Yep. So how many parentheses am I going to have total for my final answer? 3. The x plus 7. And then the x squared minus 9 is going to turn into x plus 3, x minus 3. So it's a lot of using methods that we already know how to do for factoring. It's just applying them to kind of a new situation. All right. Big GCF from the start? Yes, this one does have one. Definitely a 4. What else? X. Very good. So I'm going to start by taking 4x out of all of these and writing what's left over. 4x to the 4th power divided by 4x. That would be x cubed. Okay. Negative 16x cubed divided by 4x. Negative 4x squared. 16x squared divided by 4x. 4x. Good. And then negative 64x divided by 4x is negative 16. Yeah. Yeah, he's pretty good at mental math. Okay. Looking at what's left over, I definitely think this is going to factor more. But since it has 4 terms, what's the only way we can factor it? Group it. Yep. Group the first 2. Group the back 2. Okay. What's the little baby GCF of this first group? Baby GCF of the first group. X squared. Good. And then we're going to divide both by x squared. That leaves us with x cubed divided by x squared. X minus 4x squared divided by x squared. 4. Okay. Little baby GCF of the back group. 4. And then 4x divided by 4 would be an x. 16 divided by 4 would be a minus 4. Don't forget about this big GCF that you took out from the start. That is going to be one of your answers. So I'm going to go ahead and carry it over. And then I got to figure out the next 2 factors. We did have that matching parentheses, so that matching parentheses is going to be one of your answers. It's going to be an x minus 4. What's the other one? X squared plus 4. Now remember, anytime there's a square, we need to focus in on that and say, does this factor more? It does not. We talked about it last time. This would be a sum of squares, and does the sum of squares factor more? No. What was that word we learned for, what word represents something that doesn't factor more? Prime, yeah. This is prime, so it doesn't factor more. What were you going to say? Not factorable? All right, one last one. Looking for a big GCF from the start. Big GCF from the start. Is there one?
Yeah.
4? X. Excellent. So I'm going to take out that 4x and see what's left over. Four x to the 5th divided by 4x would be x to the 4. Minus, that's a proper way of saying it. Yes, it is. Minus, yes, 10x squared. And then at the very end, the x's would cancel, so we just need to focus on 36 divided by 4, which is 9. Okay. So we do still have some square terms here. This one looks very similar to the one we saw on the front. That kind of follows that easy factoring pattern, even though it has that x to the 4th at the beginning. So if it's following that easy factoring pattern, we're looking for 2 numbers that would multiply to 9, but those same 2 numbers need to add to negative 10. What are those 2 numbers? Multiplies to 9, adds to negative 10. -9, -1. In order to add correctly. Okay, so I'm going to bring over my 4x. Don't forget your big GCF. We're going to easy factor that. The only trick, remember, is you don't need an x and an x at the beginning because these need to remultiply to x to the 4th power. What would I write to remultiply to x to the 4th power? X squared, right. My two easy factoring numbers, one was a -9 and one was a -1. Okay. And the last thing I need to check is each of these still have the square, so we need to check if they factor more. Do they?
Yes.
Which one?
Difference of squares.
Both of them, yes. Both of them are a difference of squares. Okay, so I'm going to have a GCF followed by how many parentheses? 4, yeah. Okay, what would the x squared minus 9 factor into? X plus 3x minus 3. What would the x squared minus 1 factor into? X plus 1, x minus 1. Very good. And if you look, we have no more squared terms. We only have linear factors now, so I know definitely nothing else is going to factor more. It's a lot of factors. All right, looking at our practice SAT question, it's a graph. And we even though we haven't learned anything about how to graph a polynomial function, we can answer this question just using the knowledge from today. It says, if the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? So this key right here is what's going to help us answer it. 5 distinct zeros. What are our synonyms for zeros? X-intercepts. Now, what does distinct mean? Distinct is the key word on this. What? Clear, definitely clear. What else? Different, that's the word. 5 different x-intercepts. Not 5 of the same, 5 different ones. Okay. So looking at the first one, if we count 1, 2, 3, 4 x-intercepts. Is that the one we want to choose then? No. And you have the next one. 1, 2, 3, 4 x-intercepts again. Not that one. Okay. 1, 2, 3, 4, 5, 6 x-intercepts. Dang, that would be to the 6th power. So not that one. It's got to be D. Let's count just to make sure. 1, 2, 3. This is actually 1. It does touch it. So that's 4 and 5. Making it have to be answer D.